I promise this is the last video, and I appreciate you hanging in there with me. Hopefully you have not waited until, if you're in period 5, I hope you didn't wait till Monday night to watch the videos. You don't learn like that. Okay, please, if this is Monday night, shame on you. Procrastinated, or maybe you were busy all weekend and not shame on you. But if you did procrastinate all weekend, then shame on you. Don't do that again. I can't tell you how much I miss this stuff. I love this chapter. Gosh, it's so cool. There's so much to it, and so many things that you have to remember, and it just really challenges your brain, and it just totally wakes you up. And hopefully you're gaining an appreciation for this unit, and you're not just struggling and fighting it the whole way. Look at it as a way to really improve your brain. It really does help you with your analytical part of your brain. It helps you. You have to look for patterns. You have to try to see connections between two different kinds of problems. It's really, really beneficial. So enough said. Actually, part C here is kind of a, I don't know. I don't really like the problem because I have to write a lot of stuff down, and it's really obvious what you're supposed to do. Hopefully, after you see the problem, that you'll understand why it's so obvious. But first 4, oh, that's nice. First FOUR terms. So I'm sure, Deborah, you picked up on that right away. Write the first 4 terms in a general term for a Taylor series for, okay, so x squared f of x at x equals 1. Now, if this said at x equals some other number, then we'd have a ton of work to do. But we've already done the work to generate the first 4 terms, FOUR, for the series f of x. So if you cover up the x squared, then we already did that. Okay, so let's just look at that. So I'm going to keep my finger over that, and we have f of x equals 1 over e minus 1 over e multiplied by x minus 1 plus 1 over e x minus 1 squared over 2. Oh, we have the general term also, a bummer. And then minus 1 over e x minus 1 to the third over 3 factorial plus dot 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 plus 1 over e, and then we have a negative 1 to the n there as well, x minus 1 to the n over n factorial. I get that there, and then plus dot dot dot. I don't care how small those dots are as long as I can see them. And so there's our f of x. Well, alright, that means we can generate. Now if we did all this work, we might as well use it. That's our f of x. So if we let f of x equal that, we're good. But we want x squared times that. So let's add the x squared. That's all you have to do. X squared times this. Again, much of this unit, you're constructing infinite series. You don't always have to construct them the same way. If you have an existing series, which is what this is, it's an existing series, this f of x. The existing series, if we're going to multiply x squared by the f of x, that means we can multiply the x squared by the existing infinite number of terms. It's kind of cool we can do that. We can multiply an infinite number of terms by x squared, and we just have to see the pattern. So again, like I said, I don't really like this problem, but it is a good problem because it'll help you see that, oh, I don't have to generate the series like I did before, generating, just to reiterate, generating the coefficients, the different derivatives, and then the coefficients, and what the, here are the coefficients here, what the values of each of these functions are at where you're centering your infinite series here at 1. So we had to do a lot of work here. And that generates the coefficients of the infinite series. We have to figure out the nth term, but we have less work here. X squared times everything means x squared times every single term. You know, the distributive property. Way back when in Algebra 1, you learned that, oh, x something on the outside, you're going to multiply it by every single term, even the nth term, and so forth. So you're multiplying this by an infinite number of terms. And so we can just rewrite that. Let me scoot it on over here a little bit, as x squared over e minus x squared over e times x minus 1 plus x squared over e. So you don't have to do anything different, right? It's just you're adding the x squared over e, or you're just adding the x squared every term, minus x squared over e times x minus 1 to the third over 3 factorial plus dot dot dot. And the only thing you have to do is add that x squared right there. X squared over e multiplied by negative 1 to the n, multiplied by x minus 1 to the n over n factorial, and don't forget the plus dot dot dot, because this is an infinite series that's equal to what you see on the left hand side. And so what did we do? We really have x squared times e to the negative x. And that's amazing to me that you can rewrite this thing right here, x squared times e to the negative x, as an infinite number of terms. That is unbelievable that you can do that. I hope you're gaining an appreciation for this, and I will see you Tuesday or Wednesday